Good morning, friends. Today we'll be discussing the one more basic concept in the Verilog is the arrays. So how we are going to declare arrays in the Verilog. So what is an array? Array are allowed in Verilog for register integer, time, real time, and vector register data types. So you have multi-dimensional arrays also can be declared within any number of the dimensions. Okay, array sets can be used to connect to the generated instances. So one example which is given is the array name followed by the instruct. Okay, which is array name followed by the subscript value which can be declared. So example, here I have declared an array integer count equal to 0 is to 7. An array of 8 variables can be declared. Similarly, 32 bits for the bool value using a register I am declaring. Okay. Time checkpoint I am declaring for 1 is to 100. So 100 element time checkpoint I can generate. Okay. So register 4 is to 0, port ID 0 is to 7. So 8 port ID having each ID with a 5-bit wide. So that also can be declared. So there are still many more examples where here we have taken two-dimensional array of integer, four-dimensional array we have taken declare an array of an 8-bit vector or declare an array of a single bit pairs. So this is how you can declare array in the Verilog type. And here also you can see count of 5 equal to 0, indicating fifth bit should be made it as a 0. Checkpoint 100 bit, I am making it as 0. So a single part also you can select and you can add it the value. So this is how you will be declaring arrays in the Verilog. Okay. Next topic is on the memories. So memories, as we all know, we are going to store our data. And when you are storing our data, it can be either in a read-only memory or a random access memory or a register file. So how we are going to store that value? So those things we will be observing. Okay. In digital simulation, one often needs to model register files, RAMs and ROMs. Each element of an array is known as an element or word and is addressed by a single array index. Example, I have taken register memory 1 bit having a memory size of 0 to 1023. 1023 is nothing but 1 kilo, right? So 1 kilo bit word which I'm going to declare. Okay. Register 7 is to 0, indicating memory of this one. 1 kilobyte you are addressing. Along with that, each address will be having a width of 8 bit. Okay, that is the thing here. So memory membyte with 1K 8-bit words. Okay, memory byte 511, it is one word having the address of 511. So this is how you will be declaring the memories. Next topic is on the parameters. Okay, so parameters, why it is going to use? Because I'll just take one example that I'm taking one example, one application. I want to compare the numbers. Okay, so I want to compare 5 with 5. So when you compare 5 with 5, it is equal. Okay, when I compare 5 with 6, 5 is less than 6. When I compare 5 with 4, 5 is greater than 4. Okay, now 5 bit I'm comparing, one 5 bit value I'm comparing with 5, 4 and 6. Now I need to know how many value this 5 will be having in binary. Whether it is a 2-bit data, no, it cannot be a 2-bit data. It should be a 3-bit data. Is it or no? So 5 you are representing it as 101. Okay. 4 you are representing as 100 and 6 you are representing as 110. So when I'm comparing in the Verilog, I am comparing with bit by bit. Okay. So now 5 value is 101. One more value 5, I am taking 101. So first bit of 0th bit of 5 is compared with 0th bit of 5. Second bit 0 is compared with 0 of the second bit. 1 is compared with the 1 bit. So when all are equal, then I will be telling that this 5 number is equivalent to 5. Okay. Now the value if I change from 3 bit to a 4 bit value. Okay. So when I'm writing a program, I'm going to use this parameter, right? So what is the length of the bit which I'm going to use? Parameter n equal to 3. So whatever data will be there, it will be converted into a 3-bit data, and I'm going to use the process. In those times, these parameters are very useful. Okay, Verilog allows constants to be defined in a module by a keyword parameter. Parameter values for each module instance can be override individually at compiler time. So parameter port ID equal to 5, so I'm defining that one. Cache line width equal to 256, that I'm declaring it as 1. Okay. Parameter values can be changed at module initiation or by an using a different value. Okay, so here I'm going to show one example here. Module hello world, which I'm going to use for displaying the thing. Parameter ID num equal to 0. Initially, dollar display displaying hello world ID value. So ID num value is 0. It will be displaying. Module top different this value. So hello world 1 and hello world 2 displaying. So this value displaying hello world of 0, it has been eliminated. It will display the num1 value and num2 value. So it displaying hello world ID number 1 and displaying hello world ID number 2. This is how you can use your parameter deframe for generating the thing. One more example here is your module. My module parameter width is 7, delay is 10, width equal to, sorry, input equal to width minus 1 equal to d, input equal to clock, output equal to d, q equal to delay. So your parameter value width you are going to select as 7 value that will be displayed here. Similarly for the module top, so register value you are declaring, wire value declaring, and you are declaring my module 7 equal to 7 comma 25. It is been displayed in this value. Right. Still, there are different type of local parameters available, which has been shown here. Okay. So Verilog is here. Local parameter defined by using the local param. They cannot be directly modified with the define. So local parameters state 1 equal to 4-bit 0, state 2 equal to 1 0, state 3 equal to 1 0 0, sorry, state 4 equal to 4-bit 100. So this is our general parameter how we are going to display. Now numerical value, param value, memory value we have observed. Now we have to know how we are going to declare strings in a Verilog. Strings can be stored in register. The width of the register variable must be large enough to hold the string. Each character in a string takes up to 8 bits, which is 1 byte. If the width of the register is greater than the size of the string, Verilog fills bits to the left of the string with zeros. If the register width is smaller than the string width, Verilog truncates the leftmost bit to the string. It is always safe to declare a string that is slightly wider than the necessary. So when I'm declaring these strings, we have different escape character. So slash n, which is new line, slash t, which is used for tab, percentage symbol for displaying the things, double slash, which is used for the single one, and slash with O, character written for the 1:3 octal digit. So this is all about the string part which has been declared here, right? So these are the basic concepts regarding to the Verilog, how you need to declare about a strings, how you are declaring a memory, how you are declaring the uh, parameter, and how you are going to declare about the arrays. In arrays, again, you are having the different types, variable path select, fixed path select, right? So there are different parameters which are present. Okay, and this is also an important question from the exam point of view. Okay, so next part is about the system task and displaying the things that we will be discussing in the tomorrow's session. Okay, thank you.